I subscript x is about this integral. For real part of x greater than 0, this I will lead us to this result, and after plugging the limit of integration, we have the upper bound which collapses to 0, and the lower bound we plug into t equals to 0, so the result of integration will become as this. Then we simplify the result, so we have the final result as this. And by this result, we need to compare between integral form and the result form. First, we take first derivative of I subscript x with respect to x. We will have both result form and integral form as this, which here we just differentiate on x because this integral only works explicitly to t, not for x. Then we take second derivative with respect to x, and of course we have this both. And then the third derivative, we have this both. And then we're doing an order of differentiation with respect to x, so we get the pattern as this. Notice that we can simplify both result form and integral form by removing -1 here, so we get both result form and integral form in this blue. And don't forget the assumption that real part of x is greater than 0. And anyway, this integral result we can denote as L t to the power of n, or known as Laplace transform with input function t to the power of n, that as we know is a function of x. But now, let's focus on this blue in yellow. If we take x equals to 1, then we will have this part equals to 1 to the power of n plus 1, and here we have x equals to 1, so it only minus t. So the final form of result form and integral form will become as this. And guess what? And here doesn't necessary integer anymore. So we can define gamma capital function with input z is equals to this integral, and by the result before is equal to z minus 1 factorial. And to check the consistency of this relation, we recall the property of factorial is about this. So then we test to our integral definition as this, and notice that this part we can guess as first derivative of t with power of z. So by integration by part, we have this result. By plugging the limit through the integration, we have the first part approach to 0, and the second part is about gamma capital z plus 1. Or we can rewrite by gamma capital function as this equality, which is consistent with our definition before. And this gamma capital function, known as gamma function as extension of factorials.